I'm Dan Russell. I work at Google, and I'm a search quality user experience happiness lead in the search group. So when you use search, you're using the tools that we have to do. On my left, actually stage managing the whole thing, is Natasha Brixen-Michelson. So she's actually manning the controls here as she types furiously in response to all your chats and questions. So I've been at Google for about 6 years. And before I came to Google, I did a lot of work on the topic of today's discussion, which is sense-making. So while I've been focusing a lot on search recently, I've been thinking a lot about how we can sort of elevate everybody to the next level of search skill. And that's what this webinar is all about. How do people make sense of the world, and what can we do to help them out? Okay, so I guess all of our clocks are synchronized. It's 1 o'clock. Let's get going. We're going to be using the #sensemaking hashtag on Twitter. So if you want to post something there, go ahead and do it. And if you haven't already accepted VoIP to hear the audio, that's what you need to do. If you want to ask questions of me, please post a question to all panelists, and we'll be able to answer as many as we can. Okay? So let's get going. The first thing I want to point out is, you know, this is the way the world used to be. Remember the good old days, or maybe it's the bad old days in this case. The Reader's Guide to Periodical Literature, fabulous. I spent many hours sifting through that, trying to find the article I wanted and the journal I wanted. Well, as you know, things are a little bit better now. And in many cases, I want to make the argument that the world is really fundamentally different. In particular, with the advent of really high quality internet search, we now have the access to essentially everything. Well, you know that's not really true, but we'll talk about what it means to have access to a whole different world of content. Now, what we're going to do today is basically go through a few examples here of what I think sense-making is, and then we'll turn our attention to exactly what sense-making is from the literature. And I'll end the last sort of 20 minutes or so with some examples of tools that you can use to improve your sense-making. So let's get started. Now, sense-making is a funny term because it's used in a lot of ways. You'll see it in the literature, both the technical literature and the sort of non-technical literature, as generally speaking, what people do to sort of understand the world. But I want to give you a few very specific examples to start. So if you think about what we do in sort of the ordinary day of day-to-day science, our goal is to understand something that's complicated about the world, something that's sophisticated. And so what we do is we try to create experiments, we write papers to talk to each other, and what we do is try to figure out from the mass of data, sometimes which is conflicting, sometimes it's consonant, we try to figure out some way to express our hypothesis about the world and create a theory. So, for example, Newton's formulations of the laws of motion. You can see those have been tested many, many times, but he published first in 1687. So this is actually a scan from his original publication, showing that the laws of the planetary bodies follow these nice sort of mathematical formula. We have this very nice model. Then, 239 years later, Einstein extended that model to account for discrepancies when things are moving at very high rates of speed. And so his publication in 1916 of the relativity theory basically took the original model and extended it, or rather said, in these interesting ways, it's different. So Newton was right, but he was only right for about 200 years. And then we start to realize that we can actually make a deeper model of the world. So the sense-making here is trying to account for the extended behavior of systems, in this case, planetary motions. So another way of thinking about sense-making is sort of as intelligence analysis. So you probably remember a few years ago with the weapons of mass destruction. Well, there was that sort of failure of the intelligence analysis process that went on, and then the report came out. It was commissioned by Congress, report to the president, and there's a couple of quotes in there I highly recommend to you, right? The key here is that analysts need to be pressed to explain what they don't know. And the collection agencies must be pressed to explain why they don't have better information on key topics, while policymakers must be prepared to credit intelligence that doesn't fit their preferences. This is an interesting analytical statement, because what it means is that even people who are professionals, and our intelligence agencies really are pretty professional. They're pretty good, but when they're pressed, when they're up against the wall, when they have to do this sort of complex information management in order to make sense of conflicting data, they sometimes make errors. Truth is, we all make errors. And in particular, there's a lot of things that we can do. There's a Stanford University here near Googleplex, and I took a picture with my phone of Hoover Tower, which is that tall structure in the background there with a kind of more inspired dome. I let it analyze the image, and it's doing an image search. It's doing an image retrieval against that picture I just took with my phone. And you can see here, it's actually found the website for the picture of the thing I just took an image of. You see how this is changing. Imagine a world where you can take a picture of a bridge or a building or a house or name your favorite object, and chances are pretty good you're going to be able to find it. So we're changing from a world where you had to formulate everything as text, where you had to look things up in a table, like in the periodical guide, to a world where you can actually start to point at things, and it knows location, it knows color, it knows how to identify things that are in the world. Another example here is something like this. This is an iPhone app called TunePal. It's written by an Irishman named Byron Dugan. And the beautiful thing about this is that this actually happened to me. I'm sitting in an Irish session. That's actually a photograph I took from the music group I was in. And they started playing a tune. I had no idea what it was. None. And I whipped out the phone, I hit the app, and it tells me 30 seconds later what it is and shows me the music, which means I can now participate. Again, this is another example of the kind of ways in which search is changing. And therefore, the fundamentals of sense-making are changing, because now you get access to new kinds of data and new kinds of repositories of content that you might not have been able to ever get to before. Now you know, of course, the mechanisms are changing. I already told you about the image search, and if you've been watching the press recently, you notice that we just included image search within the regular Google image box. So you can drag an image into the image search box, and it will search for copies of that image or near hits. You probably know, if you used an Android or iPhone recently, you can talk to Google via your phone. It can tell you exactly what's going on with all the maps. Okay? Now, keep thinking out that we're growing more and more outside of the box of what you normally think about when you think of Google and what you can search for. I hope most of you know about the public data. We have Google public data. There's the URL. What you can do with this is actually go and search the different data sets. And with this kind of organizer, this kind of visualization tool, you can very easily answer fairly sophisticated questions. This is actually adapted from the original Gapminder demo that Hans Rosling showed in TED a few years ago. We acquired the Gapminder group. They came in and basically ported a whole pile of stuff, and it's just built into Google Map. So if you're trying to make sense of, say, what's going on in the world, this is a great place to go start. Give you an example. In the public data set, we have unemployment rate. And so Santa Clara County is where I live. And if you're asking the question about what's going on with unemployment rate in Santa Clara County, you might look at this and say, oh my gosh, look at that. That's terrible. What's going on? Now, hang on a second. Part of sense making is being able to take different kinds of data and put them in opposition with each other to see how they play against each other, to see how they influence each other. So what I did here is I loaded the Santa Clara County data set, and I clicked on Imperial County, which is another county in California, which, as you can see, has a far worse unemployment problem. In absolute terms, their average run rate for unemployment is around 25%, but they also have much higher swings from 20 up to 35% every year. So a plus-minus range of 15%. So by contrast, Santa Clara County, hey, we have life good. So what's going on is Imperial County is largely agricultural. But you see what I've done. I've taken one data set, imported another, and seen them by contrast. I'm starting to make sense of this data. I'm starting to understand how one data set looks in the context of another. So in my blog, I gave this as an example a little while ago. This is probably the simplest complete sense-making problem I can think of. Now, if you already know the answer to this, don't say it. But what I wanted to do is point out this is a great example of what I mean by sense-making. So I pose this problem to you. Where does the number 10 fit in this sequence? The sequence of numbers is 80, 50, 40, 90, 70, 60, 30, 20. Okay? Does everybody know the answer? Well, don't say. Okay? So here's the sense-making process I went through to figure this one out. So I'm going to recapitulate for you what I did and explain it in sense-making terms. Okay? So here I just made a little data table in my favorite spreadsheet. And I poured it in there, put in the numbers. Now, one sense-making technique, one analytic technique for looking at number sequences like this is to do various mathematical operations. So here, first thing, I noticed I all have zeros on the far right-hand side. So I thought, well, I'll divide by 10. That doesn't give me anything. So now I've got 8, 5, 4, 9, 7, 6, 3, 2. That's useless. I don't see any pattern there. So what am I doing? What I'm doing is transformations on the data set in order to look for a pattern I recognize. Okay? So when you see a sequence like this, the next thing you might do would be to say, well, let me examine the recurrence relation. So I'm going to take the number 50, subtract it from the number before it, 80, and get the result 30. That's where the 30 comes from. 40 minus 50 gives me 10, 90 minus 40. It's like, oh, this is not helping, right? So I keep fooling around. I divide by 10 and I square it. I did a bunch of operations like this. Nothing, 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 nothing. So at this point, after doing 4 or 5 more operations like this, I'm starting to think, I'm not thinking about this correctly. How else would I think about this problem? What other interpretation could I make? So in my spreadsheet, I opened up a new column and I just wrote out the names, 80, 50, 40, 90, 70. Notice anything about that pattern? Notice anything? Right. So now you see where 10 goes. Do you see why? What happened here is I'm looking for a pattern. The sense-making process, in this case, was to transform the data repeatedly, looking for another organization that allows me to basically read the answer off. So in this case, it's clear the right-hand column is alphabetical. So this isn't a numeric problem. It's an alphabetization problem. Oh, got it. So 10 goes after 60 and before 30. Okay? Pretty straightforward. So here, sense-making is looking for a representation that makes the solution of the task simple. And when you think about it, that's what all sense-making tasks are like. Let me give you another example. Okay? I was in Seattle recently, and I was thinking about, gee, you know, when it rains here, it seems different than when I'm at home in Palo Alto. So how could I understand this? How could I do a sense-making from just trying to search out the answer to doing a little bit of search plus a little bit of analysis? So for example, here, what I did was I did the obvious search. I did the search for rainfall data Palo Alto and rainfall data Seattle. And I just uploaded the data for the rainfall patterns for, I think this was the day in January. I have to go look it up. But I downloaded the 2 days, the 2 weeks, and I started looking through. Or again into spreadsheet, and look at this. The red pattern is Palo Alto. The blue pattern is Seattle. Okay? What I take from this, and this is this typical pattern when you align common days or days that are very similar in Palo Alto and Seattle. Seattle, when it starts to rain, it rains for 8 hours. It rains forever. When it starts in Palo Alto, it rains for a little bit, stops a little bit. Rains a little bit, stops a little bit. When it rains, it sometimes rains harder than Seattle, but it rains for a shorter period of time. Okay. Here's my point. When we're doing this kind of analysis, we're searching for a deeper understanding. We're not just looking for the answer. We're not looking for just a single number that says, yes, it's different. What we're looking for is this deeper representational shift so we can see the answer to the task. So here's another problem I did recently, another excellent sense-making problem. Again, this is in my blog. I'll give you a pointer later if you're curious about the details. But somebody came to me and said, look, I want to find out all the Fortune 200 companies that are older than 100 years old. So what I did was I made a Google spreadsheet, and I did an obvious search for Fortune 500 company names, and I put that, I caught that as a CSV file, and I just poured it into column B of my spreadsheet. Okay. Now what I did then is in column C, where, for example, look at cell C2 there, it looks at I wrote an expression, Google lookup, left paren B2, quote, found it, double quote. What that does, this is fantastic, what it does is it does a Google search for the property founded, meaning this company was founded on what date, what year. And it returns, in this case, the year, okay? So what I did is then subtract that year from 2011 from that year that it was founded. And I can see that in this case, this company's been around for, look at the far right-hand side, 219 years, okay? So what I've got now is the answer to my question. I could create a little spreadsheet histogram visualization of the answers here, and I know that there are exactly 5 companies in the Fortune 200 that have been around for more than 200 years. Okay? So this is now, here's the point. I'm trying to make sense of a complex data set. I don't want to go through and manually do all the searches, but I can write a very tiny script, basically a one-liner, put it into my spreadsheet, and do this retrieval. Here's my basic claim. Research, the fundamental nature of sense-making work, research, if you want to think about it that way, is that it's not just about finding the content, it's about finding the content and then transforming it into a way that you can use it. Now, truth is, you've been doing this all along for simple things, like converting, Kuwaiti dinars to US dollars, but now, Google's got a tool to do that. But now when you want to do, for example, movements of economics from one point in the country to another, you actually have to start to assemble larger data sets. That's what sense-making is all about. It's the analysis of the results of data once you've retrieved it. That's why I think about this as the extension to search. Okay, so I'm going to sort of quickly, in the last few minutes here, I'm going to leave about 10 minutes for questions at the end here. We've got 4 major tools that I don't think many people know about, and I'm going to go through them really quickly here to kind of give you a sense for the stuff you can do. This is not a tutorial in any of these, but I wanted to give you a kind of overview, a kind of way of thinking about what's possible here. So I'm going to talk about Needlebase, BigQuery, charting, and fusion tables as a way of getting people to understand the kinds of work you can do. So Needlebase is a company that was part of ITA, and when we acquired ITA, we acquired Needlebase implicitly. Now, here's the cool thing about Needlebase. What it does is it allows you to very easily describe a web page. You just do it by pointing to things on a web page, so an external website. And it does automatic web scraping. What that means is it will look at a page and automatically decompose it into component parts. Suppose, for example, you've got a website which is, say, the papers from an academic conference. You can say, here's a paper, this is what an author looks like, this is what a title looks like, this is what the organization looks like, and this is the page number, and this is the date it was printed or whatever. You describe those things and then say, Needlebase, go. It then crawls that website and automatically extracts the relevant data as tagged by the metadata descriptors you've just given it. So this is brilliant, because what you can do now is point Needlebase at a website, and it will start to import data after having crawled it. The second thing it does is once it's got data, so for example, here we've got 5 different street addresses. Now you can see here, Capitol Grill appears in Newbury Street, Boston, that Capitol Grill, Newbury Street, Boston, so on. We have all these different ways of writing the same thing. Does this sound familiar to any librarian in the audience? It should. I mean, this is authority control. So what we're doing is basically reconciling the differences between all of these and trying to normalize the data. So what you're seeing here is we now have different versions of what the Capitol Grill is, one in Boston, one in Nashville, and so on. And we combine all those, and we now have a unique, corrected, automatically corrected data set. This is fantastic. So if you go to the website, there's a really nicely worked out example there, needlebase.com. And the example I wanted to point you to, because I think it's really interesting, is there's another website called populartechnology.net, which has collected 900 peer-reviewed papers about the skeptical perspective on global warming. Now, what Glenn Anderson at Needlebase did was to write a crawler using Needlebase that went through all these papers, and that creates an underlying data set of all these 900 papers in terms of authors, journals, who's connected to who, funding sources, all that stuff. Okay. So what's happened is this has now been converted to an unanalyzed, unintrospectable, unqueryable data set into something you can actually now ask questions. So for example, you can do something like this and say, you show me out of this 900 papers, who is the most popular author and author pairs. And that's what you're seeing here. These are the most prolific teams. You can then also ask questions like, who is funding the top 10 most prolific teams, and figure out where their funding sources are. See what's happened? The great thing about Needlebase, and there are other tools like this, but this is the one we have. The great thing about it is it allows you to specify a data set implicitly, have it crawled, have that data source converted into something you can now use. Okay. Second example, Google Fusion Tables is a way of taking multiple data sets, say the output from Needlebase, and allows you to then coordinate them. So I can import, say, 2 or 3 different data sets so that you can pull them together into a single data table and then visualize the results. Okay? The simplest version of this is basically think of this as automatically creating mashups. So, for example, the mashup there on the right-hand side. Or probably one you might know a little bit better is that The Guardian in the UK took the WikiLeaks document source, wrote a simple piece of code to extract all the geolocated events, color-coded them by type, and then allows you to create this map. This is now a Google map with all the geolocated events from the WikiLeaks document corpus. Again, the same thing is happening. People are taking a large, uninterpretable corpus, or you could interpret it, but it would take you a lot of time. And now you can automatically convert, I don't know how many megabytes that corpus is, but you can easily convert it into something like this where you can start to understand what's going on. Okay? Just for amusement's sake, align those with roads, which you can also do in maps very easily, and see the correlation between roads and where these different kinds of events occurred. It's worth pointing out that Needlebase is actually free. You can go log in, create a login account, and then a couple of days later they'll give you the account. It's, I think, limited to some number of pages crawled per day, but for most people, that's probably pretty good. Okay. Third tool I want to talk about, and these are getting increasingly sort of sophisticated, so this is probably not, for K through 6 teachers, but if you run across an instance of data like this and you want to analyze it, this is a great tool. So Google has had for a long time a tool internally that allows us to do these queries against very large data sets. So the external version of this, the public version of this, is called BigQuery. Now, the reason this is kind of neat is it allows you to import very large sets of data and then do queries against it. So for example, here, the example I want to show you here is actually importing a whole bunch of metadata about Wikipedia articles, titles, people who edited it, revision dates, all that sort of information. So in this case, I'm trying to read that number. It's 20 million rows. You can see there, BigQuery/table/WP/20,100,000, anyway, 100,130. So those are individual rows. So that's a fair bit of data. Now here's what you can do with it. You can import a ton of data, billions of rows, and you can just do this. You just upload your data using the Google data upload service. And you can then make queries against that data set on the order of seconds. Okay? And a couple of different ways to do it. You can do, if you're programming, you can use the JSON interface using the API, or you can use Google Apps Scripts. So that's sort of integration for the rest of us. So what you do is you upload your raw data, and then you import that into Google Bigtable, in which you describe what the rows and columns are, and then you can do SQL. Remember what I said about SQL? Some people really need to use SQL. So this is one way to do it. And you can do select from where, so the SQL heads out there, this is where you live. You can do all this kind of stuff. So for example, here's a query where we said select the top 5 titles from this table, which is, I happen to know is the most highly edited articles of Wikipedia. So it will not surprise you to find that George W. Bush's article is heavily edited, but it's right above the list of World Wrestling Entertainment employees. I don't know why that is. That's an interesting aberration in the world that deserves some explanation. Point is, with Bigtable, you can easily hook this up to Google spreadsheets. So here, this is a query for the term Euler, the mathematician, in the Wikipedia data set. And you can see the most common reference is in the reference to the article Leonhard Euler, 2,900 different references. You can see a little histogram. But you see what this is doing for you. Now you've got enormous analytical capability using BigQuery. Once you've got that stuff in the table, you start to do your analysis. Obvious thing you might want to do is to start to chart things. And there's a great Google charting tool. It's a very simple API. It allows you to, if you know any HTML at all, this piece of code right here, which is just JavaScript, allows you to create that map on the right. Okay? So for people who do even very beginning JavaScripting kinds of things, this is the kind of stuff you can do. You can use something like Needlebase to grab the data, BigQuery to analyze it, charting API and fusion tables to start to visualize it. So we're making the whole sense-making, all those steps flow easily from one to the next to the next. Keep in mind, a lot of those visualization tools are also built into spreadsheet charting. So this is another version of the Gapminder motion diagrams. So here it's just plotting Chrome traffic versus Firefox traffic during 2010. Okay. Another one I want to point out to you is, if you don't already know about it, Google Insights for Search, which you can find by doing the Google query, Google Insights, is a fantastic resource that allows you to see what the world is talking about and thinking about at any one time. So here, what we're searching for is climate change, and there's the graph. You can see the frequency of that. Again, a way to understand a search like that is to put it in contrast with another search. So I'm going to add the search global warming. And you can see people are probably going to think about this in terms of the phrase global warming rather than climate change, because it's roughly twice as common in the query stream. See what I'm trying to tell you? There's an enormous amount of capability here. You can take these data sets and actually export them to do your own analysis on. So, summarization here. Sense-making is this whole process of trying to search for a way to organize information. And it's this, what we're trying to get to is just from simple search to search plus analysis. The key to making successful sense-making operation is this sort of representational shift. What you have to do in order to discover the right way to view that information. And finally, we've got a lot of tools out there. And stay tuned, more are coming all the time. Okay? So, a recommendation, if you want to learn more about sense-making, more about how to be a better searcher, you can read my search research blog. A couple of things I want you to keep in mind. Not only are we adding more tools all the time, but the web is constantly changing. We're getting more and more different kinds of data out there. And so if your data you're looking for is not out there today, try again tomorrow. It might be there. Okay? Finally, as interested reflective practitioner learners, one thing I want to advise you is to add a short learning element to your day. What I mean by that is subscribe to something that keeps you in touch with the space of things that are going on, the data resources, and the different kinds of ways of analyzing it. The official Google blog is good. Truth is, subscribe to something so that you get a little bit every day, so you're always on top of what's going on. And I'll leave you with one final thought, which is one easy way to do this is to play at googleday.com, which is, this is my plug. I get 30 seconds here to give a plug for a great way to learn how to search a little bit better. So here's one from the other day by David de Rothschild. Great question we posed, and then you can go and actually, once you get the answer, you can post that, and it's a great way to learn how to search a little bit better. But These are all ways of trying to inform you about how to be a better searcher, how to be a better sense maker ultimately. Thanks very much. We've got a few minutes for questions. I'm looking over Tasha's shoulder to see if anybody wants to have any questions. Yes, you can do open chat so we can see everything. I got to open my chat here. There we go. That's not that. Hello, any questions there?
Yes, we have some questions.
I'm not sure I see anything here. Oh, Tasha's scrolling through to show me what questions we've got here. Okay. Let's see here. A couple questions that arose earlier in the discussion. Should sense-making be part of university information literacy courses? Well, you know my answer on this, of course. But I think the bigger question is, I think that research as a skill is something that we pay lip obeisance to, but don't actually do much instruction of. There are people who get advanced research skills, experimental design, and so on, in advanced science courses and so on. But look, the world has changed. We have all these kinds of things, and people are asking and answering questions constantly on the web. And I think sense making, or at least better research skills, would be a really useful thing to teach. Okay, so let's see here. The second one is Google seems to be pushing more and more into search as non-transparent, personalized query rewriting, known items, simple factoid finding, question answering system. Doesn't that work against sense making? Wow, this is a long one. Wouldn't you want a more recall-oriented rather precision, or et cetera, right? So there's a bunch of questions in there. Let me answer a couple of them one at a time. So for the personalization stuff, there's been this thing with Eli Pariser about we're creating an information bubble. And Nat Cutts actually had a really nice answer to this yesterday, but I'll add my 2 cents to it, which is, first off, if you want to turn personalization off, all you have to do is log out. Personalization goes away. So then you can see the sort of, quote, canonical version. As for non-transparency, I think there's a kind of mistaken impression that there's such a thing as search neutrality. The truth is, there is no search neutrality. It never has been. Every library collection is curated. Every body of knowledge has admission and non-admission requirements to it. And so you're always seeing it through a particular lens. So I think one of the big skills here is to understand what the effects are, in the same way that people understand what the effects of, say, going to the Bodleian library are. You're not going to find the latest, greatest C++ interface programming code libraries there. So the question is, how do you understand, how do we make our searchers and our researchers more deeply understanding this kind of thing? Okay, here's another one. Same guy. Shouldn't a sense maker be able to self-select and change lenses? Well, yeah, I mean, like I said, you can turn off, first off, if you want to change the localization effects, all Google is always assuming that you're somewhere. So if you want to change your location, just change your location. It's on the left-hand side in the toolbar. So if you wanted to, for example, search from the perspective of somebody in Germany, go to google.de and so on. But every search engine localizes. It's just too inefficient to not do that. For example, if I did a search for pizza and it was non-localized, you would hate the results. Trust me, you would hate the results. Okay. So if you want to change the localization, just go ahead and do that. To turn off all the personalization effects, log out. And so I think that pretty much gets to it. If you want, I mean, we've been discussing, there have been a lot of discussions about, for example, could I make the more commercial searches or less commercial searches and so on. As you know, Google and Bing both go through a lot of trouble to make sure that those paid results are separated out from the organic results. And so once you know that, then that makes that a lot clearer. All right, and I think last question here. I love the data fill-in using the spreadsheet for the Fortune 500 example. How do you check accuracy? That is an excellent question. What I did was actually to spot check the accuracy. In particular, a lot of those companies have mergers, and so, for example, Cigna, which is one of the, if you go and look at the history of it, was acquired, and so the founded event, the founded data point, was actually tracked back to the original founding company. But that may not be what you meant, at which point you actually then have to do something a little bit more clever than what I just did. I did that example to illustrate that, and yes, you do still have to check it, but it's a lot simpler than going and doing all the original research by hand. All right, any trips, this is really the last question, any tips or tricks for breaking out and looking at a problem differently, like in the example of number series making the jump to rewriting? Oh, that is such a good question. If I knew an algorithm to teach you, I would teach you and we'd be done. I will just give you a couple of heuristics. First, a really great heuristic is to try to take on the position of somebody that's not you. So for example, I might think of a question like, if I'm trying to solve a problem, I might say to myself, well, how would Tasha solve this problem, right? How would she think about it? And take that on seriously. Second big heuristic is try to think of the negative of the question. So for example, if we're thinking about, say, what Portuguese explorers are checking out of the New World in the 15th century? Well, think about other locations. What would be not Portuguese? Well, how about Chinese explorers in the 15th century? And you'll find all kinds of interesting entanglement for that. Okay, I see we're out of time. But if you want more information, the right contact address would be TBM, T as in Tasha, B as in Brixton, M as in Michelson, at google.com. And she will give you any additional information you want. And if you've got a moment, please take the survey at the end of this, okay? Thanks very much. Thanks to all, more than 100 of you, for dialing in and sticking around to the very end. Thanks. Talk to you later.